will introduce our speaker. Presenting FHIRpath, Mirjam Baltus of FHIRly will be the speaker. She is a fire trainer and support engineer. She provides fire and SNOMED CT training courses for architects and developers. She is responsible for the support of Forge for customers like the NHS. And if you were in another session, you may already have heard that going way back, Mirjam and Eva were classmates when they were studying informatics at university. And we also want to thank our colleague Jean Duteau, who is our moderator. So I will go ahead and turn things over to Mirjam.
Yes, thank you, Pat. So welcome. Well, for those of you who've been to a previous session of mine, you know me, I'm Mirjam, and as Pat said, I'm a fire trainer at FHIRly. Because even though we co-host this event and you might think that we are event organizers, we're actually a company that can provide training, tooling, and expertise to set your fire alight. I do have my slides on the link here. It's also in the Q&A section of this session for easy access, that link. So please go ahead and download that PDF if you want to, even though, of course, the presentations will be made available after the event as well. But well, just for a sneak preview, you can already see that. So this session is about FHIRpath, and to tell you about FHIRpath, it is a path-based navigation and extracting language. So you can use it for looking at data and then extracting things out of that data. It is not the fire specification. Of course, within the fire specification, we do mention FHIRpath often, but it is a separate specification also maintained by HL7. So if you look at the release that is on this slide, it says version 2. That is not the same as the fire version that you're looking at. So that is independent of each other, something that I wanted to at least point out to you. So I have the link to the FHIRpath specification on my screen right now. That is where you can find all of the information. If you look around on the fire specification site, you can also find a page about FHIRpath, and it will detail FHIRpath, but with well, less detail than is on this particular site. So if you really want to dive into FHIRpath, then this is the link to go to. So FHIRpath is a language that can walk through a graph. It's also it uses a fluent syntax, so you can use that to create your FHIRpath expressions. And those FHIRpath expressions will be collections. It will result in collections. FHIRpath is platform independent, so you can implement it in any tooling that you need, regardless of what platform you have. And also FHIRpath, is model independent, so you can use it with other models as well, so you don't have to use it with fire, even though that is in the name, of course. That is just because this originated as a side specification to the fire specification, but you can use it for other things as well, and the FHIRpath website will detail that too. So if we look at the use of FHIRpath in fire, it is used to, for example, create search parameters and fire patch notations. I will show you a couple of examples later on, but we can navigate to parts of the data and then we can use that inside of our search parameter expression, for example. Also, you can encounter FHIRpath by looking at some profiles. Even, of course, the fire standard structures have these things that we call formal constraints or invariants. That term is a bit interchangeable, so you can see the one or the other, and then it will mean that there's an extra rule that is put upon that particular structure. Well, at the end of this presentation, I will also quickly try and show you a demo of how that works in a profiling tool. And of course, you can use it to extract data from an instance that you might have. For example, if you get in data that does not have that human readable text part set in the resource, you could extract the important parts with FHIRpath expressions from the real structured data and then fill your narrative with that. If you have a FHIR server, then FHIRpath can be used, for example, to index on certain values that are in the incoming data in order to build your index tables. So here's an example of the search parameters. This is just a very small part of the patient search parameters in the FHIR specification, but you can see that we have an expression listed. And actually that expression is a FHIRpath expression. So they can be really simple, just pointing to a particular element in that resource, but they can also be more complex with this structure here, that we also have a filter added to the expression. I mentioned the formal constraints, and those are the extra rules, and you see an example of that here, where we have extra rules on the organization resource type. So all of those expressions that you see, those are FHIRpath expressions. And perhaps for those of you who went to Doug Seven's talk before the event started, he has also shown an example of anonymizing data by using FHIRpath expressions in there as well. So if you have not seen that, then it's a good idea to perhaps rewatch the recording of that and see how Microsoft uses FHIRpath in their own tooling as well. So as I said, the FHIRpath specification is used to navigate data. So for example, we have a patient resource here, in this case in XML, but it can of course be in any format you want, as long as it has a structure. And it has to be a hierarchical structure, a graph structure, in order to be able to walk through that graph. So we have a patient with a name. The name has some data elements inside of there. There could be a second name. In this case, we don't have the data in there, but you could fill it in, of course. And then you can also find other parts inside of that FHIR patient. This would be represented in a graph like that. We have a root that is the patient beginning node. And then you have all of these elements as subnodes inside of there. Some of them might have a value and some of them might not. And of course, if you look at extension, you can see that there is, active, that there is an extension added to that active. So in that case, that node has both a value and then an extension that is a child of that node. So this is the representation that you can make from that data that you have. Now, if we want to use FHIRpath to navigate through that structure, we can use the name of the root, but it's not necessary. In this case, I have put it in. So in this case, what we are going to do is walk from patient to name and then to given. And that is the resulting collection that we get if we use this particular expression. So that will be 2 given names inside of my collection. I could have also used name.given because the root node does not necessarily need to be given. When we are going to use FHIRpath in our formal constraints, it is important on what node you are, because you are starting from that point. And I will try to make that more clear by doing that demo at the end. You can also use other parts in the FHIRpath specification to find the nodes you're interested in. So for example, by axis, we could say we can ask for the patient.children in order to get all of the child nodes for that patient node. That means that it's just the top 3. So that would be my collection of nodes that result from patient.children. If I ask for patient.descendants, it will also include all of the children from the children. So it will be recursive through the graph from that point that you have asked for. If I want to have a specific bit that I am interested in, so in this case, I'm interested in a node called use, then I can just use patient descendants.use in order to select that particular node out of the descendants. If I don't know exactly where that node will be, then this could be a good expression to use, and then you will get just that use part. So just this one will result from that expression. So as I said, in FHIRpath, everything is a collection. So you will get collections as a result of your expression, and then you can do things with that. So you could, for example, ask for the count that is the result of that particular expression, the count of the nodes inside of that collection. And that will, of course, result in an integer value. I can also select the first one, or because in a collection, the collections are ordered. So I can ask for the first thing in that collection and then walk from that path on. So for example, if you know the human name, you know that there can be 0 to star human names on the patient. So I can select the first human name that is in the patient. And then we have a list of given names inside of there. And I can select the last one of that. So that is the complete expression that results from that. If you have an element that does not have a list, like the active, because that is a 0 to 1 field in the FHIRpatient, then the first expression will just give you the same one. It will always be one result there. So in FHIRpath, you also have functions that you can use in order to make your FHIRpath expression more specific. If you want a complete overview of that, then I would refer you to that FHIRpath website, because there are far more of those functions than I am able to detail in these slides. But just as an example, we have the where function that is used for filtering. So in this case, what we can select is the patient name, where the use is set to official. So you can use a specific value you're interested in, that is the value of that node. So if we do this, then that expression will result in the FHIRpath tooling walking over all of the names and then selecting those names that have that filter, that fulfill that filter. So that have, in this case, the use set to official. So of course, we do have one of those. So that will select that name that is a part of that. So it results in the collection being this particular name. And since I didn't fill in the other one, it does not have a use set to official. So that does not fulfill my filter. If we are going to use FHIRpath to create our own formal constraints in profiling, then you will want to have an expression that results in a true or a false value. So you can, for example, test for existence in those kind of expressions. A really useful one is empty, because that will give you the answer true when that particular element does not have a value or is not present on the data. And of course, the counterpart of that is exists. And you can set any criteria you want on the exists as well in order to filter further. So the second one there is, well, filtering on the use is official on identifier. And if it exists, then this results, of course, in true. And that can then be used for validating whether the data fulfills or conforms to your profile. And you can see from this slide as well that you can have operators. So we have an AND part here inside of the expression as well. So you can use that too. So that is AND and OR, and XOR is there as well. Also very useful is the implies, because then if the first part of the expression evaluates to true, then the second part has to evaluate to true as well. And that could be a really powerful selection tool to be able to check whether something fulfills your rules that you need. Well, next to that, you can also make comparisons, you can count, things like that, and you can also do string manipulation. So you can check whether a certain value matches a regular expression that you give. That is often used for, well, for example, if you have a particular postal code pattern, then you can use this matches for a regular expression part in your formal constraint on the profile. So there's a lot of options there. And as I said, there's far more detail and examples as well on the FHIRpath website that you could check out when you are going to start creating your FHIRpath expressions. Now, I mentioned that FHIRpath is used in profiling to create formal constraints. You can see them if you have a profiling tool, and then you can check that button and add any formal constraints that you need as well. So, for example, we could have some requirements like, if you do not have a cholesterol value result in the observation, then you will have to use the note field that has to be filled in at least to indicate why a result is not available, for example. Or you could say, okay, if a date is being filled in, a birth date, that must be on or before today's date. Of course, you usually do not know the future, so you do not know whether a patient will be born then. So you will be able to use FHIRpath expressions to formulate an extra rule like this, and that goes beyond the simple cardinality things that you could perhaps already do in profiling. If we look at these requirements, you can see that the first one is using two elements. We have the value result that we use, we check for a value, and we can also use the note field. So there's two elements within that observation resource that we use for that first requirement. The second one just checks the patient's birth date field. So it's up to you when you are going to do profiling to see whether you have multiple elements involved in this rule or just a single element. But of course, it's important that you create an expression that then will evaluate to that true or false value. Now, if we are going to create those constraints, we will have to check where in the hierarchy the common parent of the nodes involved is. That can be the node itself, of course, if you have just a single node. But if multiple nodes are involved, you will check what their common parent is. And then you will put that particular expression, that constraint, on that common parent. You will have to give that constraint a key in order to be able to refer to that. And you will set whether this is an error or a warning message, because, well, sometimes you will just want to indicate that you would prefer a certain rule to be used, and then you give a warning when they don't conform to that rule. Sometimes it's a hard error, and a validator should give an error message back, or when you receive that data and it's checked against the profile, it should be rejected. So that's up to the profile author to indicate what the severity is of that particular rule. Now, let's look at that cholesterol value result. If it's not available, we want the note field to be used, and we want to put this extra constraint on our structure, on our profile. Then what we will do is, well, first we will have to translate this into a FHIRpath expression. So both being there is okay, but they can't both be empty. And this will result in an expression like that. So the value of type of quantity, because there could be multiple types in observation, value of type quantity has to exist, or the node has to exist. That is the resulting FHIRpath expression. So we put this in the common parent, the observation top level in this case, and then we refer from both the value field and the node field back to this particular constraint. So that's what is detailed here. If we refer back from those fields to that constraint, that will mean that a renderer tool can indicate that that particular field is involved in such an invariant or formal constraint. This is done in the FHIR specification itself as well, and I will show you an example in a minute. Now, if we look at those two, you can see that these are the fields, and I already gave you the answer. The common parent is the observation itself. Now, before I go to my demo, there's a couple of tools that I wanted to at least you to know about. The first is an online FHIRpath demo, so you could follow that and you would just have a website where you can fill in your data and you can fill in your FHIRpath expression and then check whether that what that results in that expression. Another one is the FHIRpath tester by Brian Postlethwaite. There's two options. You can go to the GitHub site because it's an open source project written in C#. So if you have your Visual Studio, then you can also clone this particular project and take a look at the code there. A lot of the code could be quite useful in your own project. There's also the tool available through Microsoft, which is the install of this FHIRpath tester. So that was my part of the presentation, and I would like to show you a couple of things that you could encounter there. So first of all, let me just go to this website here. So you can see I'm on the FHIRpath website there, and well, there's a lot of information. As I said, I will not have time to go through all of that. So you can see that there are lots of functions. I mentioned the existence, I mentioned the string manipulation, but you also see that there are lots of other functions as well. So please, if you are going to create your FHIRpath expressions, just check this page. It's quite a large page. Everything is on one page here, but you will see some example expressions in there that you can use. Another thing that I sometimes do as well when I create FHIRpath expressions is just check what the FHIR website itself does. So let us take a look at the observation type here. You can see that we have the observation resource. And if you encounter these I flags, that means that this element has an invariant or is affected by an invariant. This is, in this case, the top node, so it has some rules added to that, and you can see them on the side here as well. But other fields could have the I as well. So for example, here on value, there's an I, and on the data absent reason and on the reference range. And as I said, it could mean that there is a rule attached to that particular field, or it could be that this refers back to one of the more top level invariants. If you want to know what the particular rules are, you can scroll down a bit. And then you can see that there is a section called constraints, and they have this key here. That's the key I mentioned on one of my slides. You will have to invent a key that is unique within your profile. And in the FHIR specification, they have chosen the convention of using a three-letter word that reflects the name of the structure. So in this case, it's the observation resource type. It reflects the name of the structure, then a dash, and then a number. As you can see, we have 3, 6, and 7. That is because in previous FHIR versions, we had other rules as well, and they do not reuse those keys. So any rules that are now obsolete are just not in this list anymore. But fortunately, rule 3 will always be rule 3. And well, now rule 1 and 2 do not apply anymore. They are just eliminated from the list, but not reused as key, which I think is really good. The expression listed here, that's the FHIRpath expression that is used on that particular rule. You can also see the level. I mentioned rules, but rules are actually the error messages. So if you do not conform to this expression, then your observation data will not be valid. It can also indicate the level of warning here. In this case, for observation, there is no warning rules, but you can see them on other resource types. And that will just mean that you will get a warning message and still can be valid against that structure. Now you can see that you can create very complicated or a little bit more complicated FHIRpath expressions as well. In this case, well, some extra things. Of course, there's also the human readable description that you could take a look at if you don't right away understand what the expression is meant to do. So this is where you can find them in the FHIR specification. I also have the FHIRpath tester up. This is that GitHub site from Brian Postlethwaite that I really like. I use it during lots of demos when I'm profiling. So this is good to check out. If you do not want to look at the code, you can click on the releases tab. I already did that, and I think my link in my slide brings you to this particular page, and you can just download that zip file which contains the exe, so you can well, execute that particular program. It is a Windows-based program, unfortunately, so if you have a MacBook, you will have to run a virtual machine, like I am doing as well. So let me go over to that virtual machine. Hopefully it will not blank anymore. Okay, good. So in a profiling tool, as I said, you can create your own constraints. And I still have a bit of time here, so I will just go over that particular example that I had in my slides as well. So I will have to create a new profile. I'm going to create a new profile on the observation resource. So that's this one. I will not bother with the canonical URL and the name at this time because this is just a FHIRpath demo and not a real profiling demo. So I will just show you this. So I said in my slide, I have the rule that you will have to have a value of type quantity, or you will have to fill in a note. And that is something, as we already know now, is put on the common parent of those two fields involved. So that would be the value field involved and the note field involved. Their common parent is the observation. So on that level, I will have to set that constraint. So on my right here, I can see that we have constraints. You can click this open and you would see the list of current constraints that come from the FHIR specification. I will not bother you with that. We will just go and create our own extra constraint. So as I mentioned, you will have to think of a key. So I usually in demos just do Mirjam 1, but you could make it something that reflects the rule that you put in. I will have to fill in the severity. So in this case, I'll make it an error, but you could see that we could have a warning as well. And I have to fill in a description and an expression. Let me first fill in the expression. So that was that the value, if it has to be a quantity, but if it has to be on there. So value as quantity has to exist. Or node.exists, right? So that's my expression. Now, when data comes in and it does not fulfill this expression, it doesn't evaluate to false, then of course, a validator has to generate some kind of error message. Now, how does the validator know what message to generate or show to the user? That's what you put as an author in the description. So you can fill in something like this. You have to fill in a quantity. I can't talk and type at the same time. Or a note. So anything you fill in there can be used by a validator in order to show to the user what was wrong with their data. So that is now fulfilled there. So this is the first step, putting that constraint on your profile. And now what I still want to do is refer from those fields back to this particular constraint. So the value field was involved. And this is more for a rendering than for a validator, but it's still good practice to always do that. I will have to find the conditions part here. So let me see. So in this case, it's not a constraint anymore, it's a condition on this field. So that condition refers back to the constraint I created earlier. So I add a condition to the list that's already out there. And now my tooling would should have to help me. Oh, I can't see it because there's a zoom thing in the way. So Mirjam 1 is on there, so I can select that. And now this refers back to that particular Mirjam 1 constraint that I created. So as I said, a validator will not do anything about this. It was just for rendering and for humans looking at your profile to indicate this. The second field involved was the node. And that then also, of course, has to have that particular condition attached. Okay, so that is how to integrate this into a profile. And if you look at the result there, let me see if I can quickly find that. We should have a constraint on there. Sorry about the font size. I will zoom in a bit. So you can see this results in that expression in my profile being there. And this means that now a validator can consume this and can validate data against this profile and also check my particular FHIRpath expression. Now, of course, it's sometimes difficult, and I know that, to create your correct FHIRpath expression. And that is why I sometimes use that FHIRpath tester tool. So I have already opened that, but I cannot zoom in on the font size. So that's, I hope it's still readable on your screens there. What I have done is I have pasted this observation in there. It doesn't matter if you use JSON or XML, the tooling, in this case, this FHIRpath tester will be able to handle both. It also is able to handle the versions of FHIR that you see listed above. So in this case, I copied an R4 resource from the specification, but if you work with STU3 or DSTU2, you can do the same, so you can paste that in there as well. So there is an example expression in there already. I will take that away. That's just something that already popped up when you open that FHIRpath tester tool. And I want to just check whether my expression works. So that would be that same expression I did just now. Or the node. Would have copy pasted that, but okay. So you can see this is that FHIRpath expression. I have my data, I have my expression, and now I have to somehow see whether that is correct. So what I can do is either use extract if this is an expression meant to extract data from your structure. But in my case, I want to validate. I want to see whether my observation validates correctly against my FHIRpath expression. So, yes, fortunately it worked. For a moment I thought that my virtual machine was frozen there. So you can see that we have this value true. Okay, now you say, yeah, nice, Mirjam, you've prepared this. So you could have put in anything there and it would have said true. But of course, I did test this and this is a correct expression. And I can see that because if you look at this here, you can see that we have a value quantity. So the value quantity part of my expression is evaluates to true. So it is true that there is a value quantity on there. By the way, there is no node on this particular structure here. So it should give me a different result if I did not have that value quantity. So let me just quickly make it a value string, which is also one of the data types that you can use to fill in a value on the observation. So now,
Mirjam, we do have 5 minutes left.
Okay, thank you. So now this particular expression should not result in true anymore. I can validate that, and you can see we have a false in there. So this is a good way to test your expressions, but please do know if you're further down in the hierarchy, in this case my expression was on the top level, but if you put an expression further down, you will have to, in the FHIRpath tester at least, put in the full path, because it will start on the top. It will start on the top of my observation here. Whereas when you are in your structure, you're already on a node deeper in the hierarchy, so you can eliminate the first part. So that's a small difference between what you can put in the expression in the FHIRpath tester and what you would put in your profile. But other than that, it's a really powerful tool to help you out with testing there. So that was what I wanted to tell you and what I wanted to show you. Perhaps Jan, can you help me out with looking at the questions to see if there's a question that I can still answer before it's time?
Yeah, we haven't had any questions so far.
Okay. Well,
so
then
you've done a good job.
I either have a public that is not listening or is completely baffled by what I'm saying, so they don't know what to ask, or I was very clear. Well, hopefully I was clear enough, but as I said earlier, if you have any questions, go to the Q&A for this session. I will monitor that for the rest of this particular Dev Days. So if anything comes up later on after this session, or if you review the video tomorrow, then just please let me know with a Q&A or send me a message in the Whova app, and I will reply to that. Okay, so then we are running a couple of minutes early, but well, this was what I wanted to show you. Thank you all for your attention. Hopefully it was interesting for you to at least get started with FHIRpath. And I hope to see many complicated FHIRpath uses and expressions in the future. So thank you all for attending, and we'll see each other.
All right, thank you, Mirjam, and thank you, Jean, for moderating. And as she mentioned, the Q&A, if there are any questions that come up, it will be persistent, and you can check those out in the Whova app. And you can check the agenda in the Whova app to get to the closing session for today. Thank you very much for attending.